Hi, hello guys, this is Vijay, chemistry lecturer from Ailebad Junior College. As you know that we have started our NEET series. Based on that, we are discussing about NEET chemistry and NEET biology in detail with each and every chapter. In that category, today we are going to discuss about NEET chemistry unit 3 periodic classification. From this particular unit, we are going to discuss about few important topics. Let's start. Now, let us talk about the characteristic features of this long form of periodic table. Okay, the most widely used periodic table nowadays, which is called as the long form of the periodic table. This is constructed on the basis of repeating of electronic configuration of the atoms when the elements which are arranged in the order of increasing in number of atomic number, not atomic weight. Okay, long form of this periodic table, that is very clearly shown that the arrangement of elements in a systematic manner, and that could help us to study each and every elements in detail and their physical and chemical properties in detail. Okay, now let us see the major characteristic features of this long form of the periodic table. Okay. Okay, so the long form of the periodic table, that could consisting of two different major components, like one is said to be the horizontal rows, which are also called as periods, where the vertical columns, which are also called as groups. Okay, so that is the first and fourth most important characteristic features of long form of periodic table: horizontal row and vertical column. And these horizontal rows are also called as periods, and these vertical columns are also called as groups. Okay, so in the long form of the periodic table, we could able to see there are altogether 7 periods, and these were numbered to be 1, 2, 3, 4, 5, 6 and 7. So these are the 7 different periods. Similarly, there are 18 groups that been placed in the long form of periodic table. 18 groups are being placed. Now let us see this. The first period, which contain only 2 elements, and the subsequent periods of the other, which consisting of 8 and followed by 8, 18, 18, 32 and 32 elements respectively. Okay, 14th elements of both 6th and 7th period, which are commonly to be called as lanthanides and actinides respectively. Okay, these were placed in separate column at the bottom of the periodic table. And when we are talking about these groups, in the earlier period, these groups were designated as 1A group, 1B group, 2A group, 2B group, respectively 8A group and 8B group, or 0 groups. According to the new recommendation, it's been recorrected by IUPAC, International Union of Pure and Applied Chemistry, the groups being numbered from 1 to 18. So there are 1 to 18 groups are being numbered. Okay, so these were discussed in detail in the long form of periodic table. Now let us talk about these periods. So as I said in detail about the horizontal rows, which are also called as periods, and that have been denoted as 1 to 7. A horizontal row which is in the period table are called period. In terms of this electronic structure of the atom, a period that could constitute a series of elements whose atoms that have same number of electron shell, principal quantum number is n. Thus, the periodic period that could indicate the value of the n for the outermost or the valence shell of the atom of the element, and this could be explained in higher principal energy level as n value is equal to 1, n value is equal to 2, n value is equal to 3, etc. And there are 7 periods, and each period starts with a different principal quantum number. So their principal quantum numbers are different, that could start from n value as 1, 2, 3, 4, 5, 6 and 7. It can be seen that the number of elements present in each group, that is twice the number of atomic orbitals which are available in the energy level that is being filled. Okay. Now electronic configurations of the elements, how far it is there in the periods, let us see. Now let us talk about the elements of first period. Okay. So the first period that could be corresponding to the n value as 1, n is equal to 1. Yes, it is unique because it contains only 2 elements as comparing to other elements which are being placed with 8, 8, 18, 18, 32 and 32. This is not surprising because the first energy cell, that is called as K. Yes, we are denoting the first energy cell as K and followed by K, L, M and N. Now let us talk about this K that has only one orbital. So one orbital, that value is what? 1s orbital. As we know that the shape of the s orbital, that is spherical, and that could accommodate only 2 electrons. This means that there can be allowed for only 2 elements, and that could be present in which 1 or 2 elements in this particular period. So this is the first energy level, the first period that could contain 2 elements. They are called as hydrogen and helium. That could be denoted as 1s2 and 2s2. That could be denoted as 1s1 and 1s2, like hydrogen and helium. Okay. Now talking about elements of second group. Okay. So again I am going to repeat about these elements of first period. It is not group, it is period. See, elements of first period. The first period that corresponding to n value is equal to 1, and that is unique because it could contain only 2 elements present in this first period. The reason is the n value that is equal to 1, and this is the first energy cell, and the first energy cell to be denoted as K. Now the first energy cell that is denoted as K, that has only one orbital, that is what? 1s orbital. As we know the structure of s orbital, that is spherical in shape, and that could able to accommodate only 2 electrons, right? So this means that there are only 2 elements can be accommodated in which 1 and 2 electrons that could be present in the first energy cell of K. So that could be denoted as 1s1 and 1s2, and these 2 elements are to be respectively as hydrogen and helium. So this is about the elements of first period. Now let us talk about elements of second period. Okay. So now talking about these elements of second period, the second period that could contain 8 elements. Here we can able to see 8 elements, whereas in the first period that we could able to see 2 elements. Okay. So elements present in the second period, which are 8 elements, because n value here it is to be considered as 2, whereas the energy level that could be considered as L. Yes, the earlier one we discussed about K and this is the second energy level, that is called as L. Okay. So in L you can see there are 4 orbitals could able to seen. So 4 orbitals are nothing but 1 2s and 3 2p orbitals. Okay, so there are total 4 orbitals can able to see in the elements of second period. So 1 2s orbital plus 3 2p orbitals we can able to see 3 2p orbital. This 2p orbital to be considered as 2p of x, 2p of y and 2p of z. So these are the three different orbitals that could be able to see, right? Now overall we can see there are 3 p orbital and 1 s orbital. So overall 4 orbitals can able to see in the elements present in the second period. Okay, so there are 4 orbitals that could have the capability or the capacity of 8 electrons. So the second period that could able to show 8 elements that could be present in the second period, in which that could able to start with lithium. Its atomic number is 3. Okay, so the elements present in the second period are 8 elements, and that could start from the atomic number 3, because the elements of first period that already we have discussed, hydrogen, helium, their atomic number are respectively 1 and 2, and followed by atomic number 3, that is lithium, that starts from these elements present in the second period, where the energy level to be considered as L. Okay, now it starts with lithium, in which one electron that could enter with the 2s orbital, and the period ending with neon, which has the atomic number 10. So here we could able to see the comparison between this lithium and neon, where one electron that could enter with 2s orbital, and the period that is ending with the neon, which has the atomic number Z is equal to 10, in which the second cell which is going to be completed with 2s2 and 2p6. There we can able to write the electronic configuration for the neon, that is 2s2 and 2p6. So there are 6 plus 2, overall 8 electrons could be possible. According to that, 8 elements could be possible in this particular period. Okay, so this is about the elements which are present in second period. So now let us talk about these elements of third period. In the third period, which is corresponding to the n value that to be considered as principal quantum number as 3, n is equal to 3. There we could able to see 9 orbitals. So this should be written in the form of 3s and 3p and similarly 3d. So total 9. So 9 orbitals could able to be seen in the elements which are present in the third period. Okay, however, we know that the energy level diagram for the multi-electron atoms, which are like the 3d orbitals are higher in energy, which is comparing with 4s orbital. So in this particular period we could able to see that is involving for filling of only 4 orbitals which are containing 8 elements, and these 8 elements that could able to start from sodium Na, and which has the atomic number of 11, and that end with the argon, which has the atomic number is 18. Okay, so these are the elements could be seen in the third period. So based on that, the elements are being accommodated. So now let us talk about the elements which are present in fourth period. The fourth period, which is corresponding with the n value, that is n is equal to 4. Yes, right, which involves the filling of 1 4s and 3 4p orbitals. So in between these 4s and 4p orbital, 5 3d orbitals are being filled, which have energies in between these orbitals. We could able to see in this particular period there were 18 elements in which starts from the potassium. Its atomic number is 19, and that leads to the krypton, its atomic number to 36. In this period, we come across the elements which involving for filling of 3d orbitals. These are all known as transition series of element. This transition series of element that could starts from Scandium, its atomic number is 21, which has the electronic configuration of 3d1 and 4s2, and that could end with zinc, its atomic number is 30 with 3d orbitals completely filled, which are having the electronic configuration of 3d10 and 4s2. So these are the different elements that could be seen in the elements of fourth period, right? Now let us talk about what are the elements present in the fifth period. The fifth period, like the fourth period, which also consisting of 18 elements, that begins with rubidium. Its atomic number starts from 37, which is filling of 5s orbital, and ending with xenon, that is like its atomic number is 54, that could be filled up with 5p orbitals. This particular period also contain 10 elements of 4d transition series, that is starting with yttrium, its atomic number is 39. So these are the elements that could be seen in elements of fifth period. Now let us talk about the elements of sixth period. Elements of sixth period that could contain of 32 elements. Its atomic number that starts from 55 to 86. The successive electron that could enter into 6s, 4f and 5d and 6p orbitals. In order to that, it starts with cesium, its atomic number is 55, and ending with radon, its atomic number is 86. Okay. Here also we could able to see the elements which are having the inserted elements. They are also called as the inner transition series or the lanthanide series, that could starts with cesium, Z equal to 58, and it is ending with lutetium or lutetium, its atomic number is 71. Now let us talk about these elements of seventh period. Elements of seventh period, which is also similar to the sixth period, with the successive filling up of the 7s, 5f, 6d and 7p orbitals, that includes most of the man-made radioactive elements. In this period, this period end at the element with atomic number 118, which would belong to the noble gas family. Some of the elements of this particular period, they have been recently established and named. This period are also contain 14 elements which involve the filling up of 5f orbitals, which is starting from actinium, its atomic number is 89. This is also called as 5f inner transition series, which are also called as in another term as actinide series. So far we have discussed in detail about the periods, horizontal rows or periods which is present in the long form period table, that starts from 1 to 7 respectively. In this there are few more important points that to be noted. They are the first three periods which contain 2, 8 and 8. These elements are present. They are respectively called as the short period. Similarly, the next three periods which contain the number of elements in each period are 18, 18 and 32, and these elements are respectively called as long periods. So these are the entire detailed study about the elements present in 7 different periods. Okay. So now, so far guys, we have discussed few major topics from Unit 3, classification of elements and periodic properties in detail. And this particular unit we will continue with one more video. Until then, thank you guys.